Good morning and good evening, everyone. So welcome to this session where we will learn on time series analysis using R programming language. So this is basically a mini project where we will look at time series data and how we can analyze it, visualize it to basically find some important information or gather insights from the data. Now, when you talk about time series analysis, time series is basically any data set where your values are measured at different points in time. So when you talk about time series data, data is usually uniformly spaced at a specific frequency. For example, hourly weather measurements, you have daily counts of website visits, monthly sales total, and so on. So when you talk about time series, that can also be irregularly spaced and sporadic. For example, timestamp data in computer systems, event log, or history of 9/11 emergency calls. Now, when we work with time series data, for example, here I'm taking a energy data set, we can see how techniques such as time-based indexing, resampling, rolling windows can help us explore variations in electricity demand and renewable energy supply over time. Now, here we will look at some aspects of this data set which I am considering. So this is open power systems data set, and here is the data set I have. We can look at the data set. Now this is in a simple format. It has time. It basically has values for consumption, and then you have data for wind and solar and wind plus solar. So in certain cases you have only the date and the consumption, but then if we scroll down we will also find data for wind, solar, wind plus solar, and so on. So this is a time series data set which we would want to work on. Sometimes you may also have the data collected which just does not have the time, but it may also have timestamp. That is, it would have, say, hour, minutes, and seconds, and that can also be worked upon. So let's consider this data set and let's work on this project where we will analyze this time series data set. Now here we can work on this time series data. We can basically create some data structures out of it, such as data frames. We can do some time-based indexing. We can visualize the data. We can look at the seasonality in the data, look at some frequencies, and also do some trend detection. Now, when you talk about this data set, it has electricity production and consumption, which is reported as daily totals in gigawatt hours. And here are the columns of the data, which I was just showing you. So you have data, you have consumption, you have wind, you have solar, and wind plus solar. So this is the data we have, and we will basically explore, say, electricity consumption and production in Germany, which has varied over time. So some of the questions which we can answer here is, when is electricity consumption typically highest and lowest? How do wind and solar power production vary with seasons of the year? What are the long-term trends in electricity consumption, solar power, and wind power? How do wind and solar power production compare with electricity consumption, and how has this ratio changed over time? We can also do wrangling or cleaning of this data or pre-processing of data and create a data frame, and then we can visualize this. Now let's see how do we do that. So I will open up my R Studio and let's look at the data set. So here is the data set. Now I'm picking it up from my machine. You can also pick it up from GitHub. So all the data sets or similar data sets can be found in my GitHub repository. And here I can look in the data sets. You will find a lot of different data sets here. There are some time series data sets such as power. I can search for power, or you have basically coal, or you have this OPSD Germany daily data set, and there are many other data sets which you can work on. Now, to get the documentation on this project, you can also look in my GitHub repository and you can search for repositories, and then basically you can look in data science and R, and here there is a project folder where I've given the documentation, sample data set, and also your time series analysis related document. This is also the code which you can directly import in your RStudio, and you can practice or work on this project. So let's see how does that work. So first thing is we will create a data frame from this data set. Now here, if you see, I am using header as true so that it understands the heading of each column. I'm also giving row dot names and I'm specifying date. So there is this date column in the data set as I showed you earlier. Let's look at it again. So you have date, consumption, wind, solar, wind plus solar. So you can suggest that date should become the index column, which can be useful. So you can do this. Now let's just create this. Let's look at what does this data frame contain. And here, if you see, it shows me some data which has been now as a part of this data frame structure. It starts with consumption, wind, solar, wind plus solar. And if you see, this one is becoming my index column. So I can always do a head and look at part of the data frame using head or tail. So look at the first records. So let's see this. Now that shows me the head data. I can also do a tail and look at the ending values. So if you closely see here, we have wind, solar, wind dot solar, and that basically has NA values. So there are missing values, but let's look at the tail, and that tells me that there is some data available for wind and solar and wind solar. Now we can always look in a tabular format using view, and we can look at the data. So this shows me that there are values in these columns. We see NA values, but if I really scroll down, I can see some values which would be available for wind and solar and wind solar. So I can just use view. Now I can look at the dimensions of this particular object, and that tells me there are 4,384 rows and 4 columns. You can always look at the structure, that is check the data type of each column, which can be very useful. So if I see here, I don't see the date column because date column was considered as an index, which can be useful. But I also look at my other columns, so they are of the num types. So that's the data type for each attribute or each column here. Now we would be interested in looking at this date column. So let's look at the data type of this date column. Now if I try to do this, this will show me that this is null because date as a column does not exist because we created it as an index. So if I look at row names and then I search for my data, show me the index column or row dot names, it tells me these are the values, that's the date column, which we are seeing here. Now we can access a specific row by just doing a my data and give the index value or row name value. So let's look at that, and that shows me based on this index you're looking at the value. You can obviously search for a different date, something like this. You can also pass in a vector and you can give range of values. So that is 0, 1, 2006 to 4 of January. And we can look at this one. So it shows me these are the values. So here actually I'm not giving a range, but I'm just selecting multiple values from row dot names. Now we already know that in R you have a summary function, so you can always do a summary, and that gives you for each column, it gives you minimum, first quartile, median, mean, third quartile, and maximum values. So we are looking at consumption, we are looking at wind, solar, and wind dot solar. Now this is good, but then if I would want to really visualize the data, access the data, do some analysis, then it would be good to take all the columns, and then we can later decide to change the data type of say date column if we want to use it. So earlier I was using date as row dot names or the name of the rows or index, what you call in any other programming language. So here I will just use my data set and I'll say header as true. I'm calling it my data 2. Let's look at the data, and this one shows me 5 columns, wherein my first column is the date, consumption, wind, solar, and so on. Now, looking at the structure, so let's look at the data type. So it tells me that if now I'm interested in looking at the date column from my data to data frame, it tells me it is a factor with 4384 levels, and these are the values. So it is not in a date time format, it's a factor. Now what we can do is we can convert this into a date format. How do we do that? So let's have a variable x, and I'm going to use as.date function, and I'm going to pass in my date column. So that's assigned to x. Now let's look at the head of x, and it shows me the values. We will also see what kind of class it is, and we will look at the structure of x. So class already says it is date type, and look at the structure, so it shows me the format. Now we have converted this column or column related value into x. Now how do I basically extract values out of it or make it a part of data frame? So first I will use, so all once it has been converted in date format, I will go for as.numeric, and here I will create a variable called year, and I will just do a format on x, which is basically of date type, and then I'm saying %y, so that will get me the year component out of this. Let's look at the values. That shows me year component. Now similarly, we can get the month out of this, and then basically look at the month values. We can get the day out of it, and we can get the day component. Now if I look at my data 2, which we had created earlier, this basically had date, consumption, wind, solar, wind, solar. So what I can do is I can add these extracted columns such as year, month, day to my data frame using a cbind, that is column bind, and I will assign it to my data 2 again. So let's do this. And now if you look at head, it shows me date, so that should be date format, consumption. Now this one might not be date format, but we'll see. You have consumption, wind, solar, and we have extracted the year, month, and day, which can help us for group by. We can do some aggregations, we can do a plotting, and we can do various things by these additional columns. Now let's look at first 3 rows here. So I'll say 1:3 for my data 2, and that shows me some data here. You can always do a head and look at the sample of data. So that basically shows me month, day, your columns, and then you have your date. Now what we can do is we would want to visualize this data. We would want to basically understand the consumption. Now as I said, if we want to visualize the data, say for example I want this, which is consumption of data over years, and this one is in terms of gigawatts per hour, as we were mentioning here, gigawatt hours. So if I would want to create this visual to basically understand the pattern of the data, how do we do it? So we can create a line plot of full time series of Germany's electricity consumption using the plot method. Now how do we do that? So here one of the option is I can straight away use the plot method. I can then say what would be in my x-axis, what would be on my y-axis, what would be the type of graph I would want to plot, what is my name on x-axis, y-axis, and this is the simplest way. So I'm saying my data 2, I'm extracting the year column, and here I'm taking the consumption. So let's create a plot. And here, if you see, we are looking at a plot. We do see some tick times, and we see that the data has been divided with every 2 years. So from 2006 onwards to 2016. But then really this data does not give me a very useful way of looking at the data or understanding it. Might be what I can do is I can use the same way, but I can give, apart from x-axis and y-axis, I can say the limits, that is x limit is 2006 to 2018 and y limit is from 800 to 1700. So we can do this, and let's look at this again. This is a plot, but it really does not help me in visualizing and understanding the data. So what are the better options? I can go for multiple plots in a window. As of now, we are just sticking to one plot in window. So if you would want to have multiple plots, you can always change the value here and make it 2 or 3. That will say how many rows and how many columns. So as of now, we will just keep it as it is, par mf row. Now, if I would want to plot, I can straight away give the column name. So I'm interested in getting the consumption. Now I can just do a plot. I'll say my data 2, and I will choose the second column, which is consumption, which we saw here from our data. So consumption was the second column. So I can just do a plot in a straightaway way without mentioning your x-axis, y-axis, limits, and so on. And if you look at this one is giving me a pattern. Now here I am looking at x-axis, y-axis, which is not really named. We do not have a name to this graph, and we are looking at the data. It does show me some kind of pattern, but might be we can make it more meaningful. So I can do it this way, where I say my data second column, let's give axis as year, x-axis, y-axis is consumption. Now that has changed, the x-axis and y-axis. Now I can also give some more details. I can say type should be line. I have the line width. I'm saying color is blue. And let's do this. So this looks more meaningful, might be shows a wavering pattern of consumption over years. I can also give a limit of X, that is 0 to 2018, and that basically shows me the range. Now we can change that and we can be more specific and saying X limit should be 2006 to 2018. And let's look at this. Now this one, once you have given a proper limit, it shows the line graph and it shows what was the consumption in 2006 and over a period till 2018. I can then use any of these options are fine, but it depends on what and whom you are presenting the data or what kind of analysis you're doing. So I can do a plot. I can choose column second, X lab, which is x-axis, y-axis, type is line, width, giving a X limit, Y limit, and then I'm giving a title to this, which is consumption graph. And then basically you're looking at the line graph. Now, those are the options which you can do. Either you could be very specific, or you could just give your column which you want to plot, or obviously make it more meaningful by giving all the details. Now, what we can do is, if we would want to look at this data and understand it better rather than just looking at a simple line, I can take the log values. So here I'm saying log of my data to second column. So I'm taking log values of consumption and I'm taking the difference of logs. So I can say difference, and then you can basically increase or decrease this by multiplying it by some number. So rest remains the same. I'm changing the color, and let's look at this plot. And you see, this basically is giving me a better pattern which makes meaning. Here we see the log values. So this is, you are using a simple plot function. In R, you can also use ggplot. Now for that, we can install the ggplot package. It's already there in my machine, so I'll say no. I will access this by using the library ggplot2, and now I can use ggplot to plot. So the way you specify here, you can say my data 2, that's the data frame. I'm saying type as O, and when I'm saying line, I am basically going to use x-axis, which is year, y is consumption. And let's look at this plot. So again, we are back to the one which we were doing earlier. Really does not make any sense. It gives us some data, but then really does not give me enough information. I can, in my aesthetics, I can say X as year, Y as consumption. I can do a grouping, and then I can give line and plot. So again, we have some information, but really does not help me, right? Now let's look at other example. So I'm just doing the same thing here, and I'm looking at line type being dashed. I'm using the ggplots other methods such as geom line and geom point to give me more information. And if I look at the plot, it does give me data. It tells me what are the different values. It gives me some kind of pattern, but I would still prefer the way we were doing with plot. Now, we can change the color and obviously add details to it. So what we see is when you use the plot method, which I did earlier, it was choosing pretty good tick locations, that is every 2 years, and labels the years for the x-axis, which was helpful, right? But with these data points, which we were seeing here, or say, for example, this one, or say this one, or say this one, we are looking at some data, but then that really is quite crowded and it is hard to read. You can look at the values, but then it really does not give you enough information. So we can go for plot method, but then we will see how we can consider different data. Now, if I would want to plot the solar and wind time series, so let's see how do we do that. So wind column is what I'm interested in. So first thing is, it was always good to find out the minimum and the maximum values in every column. So I'm saying minimum, I'm saying let's put in here my data 2, and then let's look at the values. So we are looking at the columns. We know consumption is the second column, wind is the third column, and you have solar as the fourth, and this one is the fifth. So let's say, let's find out the minimum of each of these columns which we would want to plot. So let's say minimum of data third column, and here I'm also saying remove the NA values because we do not want to consider the NA values. So let's look at the minimum. That shows me 5.7757. What is the maximum value? It is 826. So that also helps me in giving a limit. If I want to plot wind on y-axis, I can give a y limit from 5 to 850. Consumption wise, let's find out the minimum from second column and maximum. And similarly for solar, find the minimum and maximum, and wind plus solar, minimum and maximum. So this will be helpful when you would want to plot multiple graphs or give some limits. So that's fine. Now for multiple plots, as I said, instead of having one plot, let's plot consumption and wind and solar and try to see a pattern. So I can say par function, and I will say 3 rows and 1 column. So now when I start plotting, you will see you will have multiple plots in one single window. So let's see how we do it. So here, let's look at plot 1. So this one is consumption as we did earlier, and let's look at the data. So that gives me some data. You can always do a zoom and you can look at the data. You can basically expand this graph or you can reduce this graph to see what kind of pattern we have in consumption. Similarly, we can basically choose date being x-axis, my consumption being y-axis, right? So this is being more specific because here we have a range, but it really does not give me enough information. So I will basically give x-axis, y-axis. I will give the name, that is daily totals, and then I will basically give consumption, color, and y limit based on my minimum and maximum limits. So let's do this, and now we can look at the data here. So let's see, this data makes a little more meaning because we are looking at the dates. And let me do a zoom. So it shows me all the dates. It shows me the data points. It shows me how the data pattern is changing for consumption. Now, this is for consumption. So what we can do is we can also extract specific data. So if you see here, I have done some testing where I'm saying, okay, I would want to get a date specifically. I would want to extract some value. So we are looking at the date column, but if you remember, we did not change the data type. We just changed the data type of date column. We extracted year, month out of it. It would be good if we can convert a column into date time format and put that in our data frame. Now, let's look at the plot 2. This is mainly for your column which should be consumption and wind and solar. So here I see it is solar data, and I can plot this one to see how it looks like. And that tells me from 2006 onwards we have some pattern. I can be more specific where I say I would be giving date and then the column for solar, x-axis, y-axis, what is the type, what is the y limit, and what is the color. It is always good to specify your x and y axis, give a name rather than let it automatically pick up. Now this makes more meaning because it shows me some dates. Similarly, we can do for wind. So either you do it just by giving the column or you give your x and y axis. So let's look at this one. And this shows me the data. So we can choose plot 3. This one we can choose plot 2. We can choose plot 1, and we can put all that data in one graph. So that's when you are putting in multi plots in one particular graph. You can always do a zoom. You can always look at the data, right? And this is usually useful to look at the pattern, what kind of pattern we see, what data we have, and so on. Now, moving forward, so we have seen how you are creating these plots all in one window. Let me reset this back to one plot per window, and let's basically plot time series in a single year. So what we have seen is that when you look at the plot method, it was quite crowded. Then we looked at solar and wind. And if you compare that, you will see your consumption pattern, your solar pattern, your wind pattern, and basically we can see from this particular data some kind of pattern. So electricity consumption is highest in the winter, where we will see what is the consumption. Is it highest in winter or is it in summer? We can see that by breaking a year further into months, we can see that. But we see a pattern which goes for every year or every 2 years being highest at a particular point of time, and then it drops down. So electricity consumption is highest in winter, and that might be due to electrical heating and increased lighting usage, and lowest in summer. Now, when you look at electricity consumption, appears to split into two clusters. We can always look at the consumption, one with oscillation centered roundly around 1400 gigawatts. So you can always look at 1400 gigawatts and you see all the values here which are in that particular consumption. Another with fewer and more scattered data points, centrally roughed around 1150. So if you really expand this, you can see you will have a lot of data points at this point. Now, we might guess that these clusters correspond with weekdays and weekends, which we can see if you break that data into yearly, monthly, weekly, and so on. Now, if you look at solar production, that is highest in summer when sunlight is most abundant, and lowest in winter. So obviously when you're making or gathering some insights, when you're looking at the data, you are also using your domain knowledge, your business knowledge, your knowledge of business to understand how this goes. If you look at wind power production, that's again highest in winters and drops down in summer. So due to stronger winds and more frequent storms, and lowest in summer. So there is some kind of increasing trend in wind power production over years, which we can see here over the years. And all the time series data what we are looking at is referring or showing us some kind of seasonality. That is, we are looking at seasonality in which a pattern is repeating again and again at regular times, at regular intervals. So if you look at consumption, solar, and wind time series, that oscillates between high and low values on a yearly time scale, which we can break down and see. I'll show you that. It corresponds with the seasonal changes in weather over the year. So seasonality does not have to correspond with meteorological reasons. For example, if you look at retail sales data, that will show you yearly seasonality with increased sales in particular months. So seasonality, when we say, can occur on other time scales. So the plots what we are seeing here, they are fine, but if you look at those plots, they might show some kind of weekly seasonality also. So in your consumption. corresponding to weekdays and weekends. So let's plot for one single year. Now, how do I do that? So first is I will look at my data 2. That shows me the structure. It shows me date, which is factor, other columns, which are all numerics. Now, like we did earlier, I'll repeat this step where I'm going to convert the date column into date type, look at head of it, look at class of it, look at the structure of it, right? And then what I want to do is I want to add this to my data frame. So I will create a variable called mod data, and this one will have as data, and I'm formatting the value of X, which is date time, into month, day, and year. So let's do that. And now you look at the mod data, which I created, like modified data. So this is the format I have. It is in date type, if you carefully see here. And then I can look at the head of it. So it says me mod data. Now what we did here is when I said my data 3. So my data 3, we did a cbind and I did a mod data, which is going to add this column to my other columns of my data 2. So my new data frame is my data 3. Let's look at the structure of it, and you see there is this date column. I can delete it, I can remove it, I can let it be, right? So that depends on our choice. Might be we want to, once our analysis is done, we want to remove the mod data, right? So we can keep both of them. Now let's basically extract data for a particular year. Now how do you do that? So this is some wrangling. So I will say my data 4, let's call it my data 4, and I will use subset function. So subset will work on my data 3, that's the data. And what I'll do is I will do a subset. How is the subset found? So I'll say take the mod data column, the value should be greater than or equal to 2017 and should be less than 2017 December 31st. So I'm getting data for 1 year and I'm storing it as my data 4. Let's get the head of it, and you see we are specifically looking at 2017 related data. Now let's do a plotting of this where I will only create a plot for 1 year. So I'm saying my data 4, that's my new data what we got. So here I am going to take the first column, which is mod data. I'm going to take the third column, which is consumption. So I'm looking at the date format for 1 year, consumption values for it, and then rest of the things as we have done earlier. Let's look at the plot, and this makes more meaning, right? So when you look at this plot, it tells me Jan to Jan. It shows me some kind of pattern where I have divided the year into months, right? And it is broken down into say 2 months, so Jan and March and May and July and so on, but we still see a pattern, and that gives me good understanding of pattern where I've broken it down into months. So this is where you have taken time series in a single year to investigate further, and this is what we see, right? Now we can clearly see there are some weekly oscillations. What one more interesting feature is that at this level of granularity, that is when you're looking at yearly data, there is a drastic decrease in electricity consumption in early January and late December during the holidays, or probably we can assume that this is holidays. Now I can zoom in further and look at just Jan and Feb data. Let's see how we do that, and let's see how we work by zooming in the data further. So to zoom in the data further, let's see how we do it. Now here we have this my data 4, which is basically having a subset, right? So let's work on this one. So I will say my data 4, which earlier I was taking data 3, I was doing a subset and I was giving the date, but this time I will make it more narrower. So I'll say my data 4, I will say subset from my data 3, and I will choose mod data column, which we have modified with the date format. I will choose the starting date as 1701, that is Jan, and then let's go till Feb. and let's create this. Now let's look at the head of this. So it shows me we have the data which is Jan, and then you can basically look at more on this. Now again, as I said earlier, let's find out the minimum of this from the first column. So that is basically your mod data. So let's look into this one, and that basically will give me minimum and maximum. Let's look at the values. So this one tells me Jan 17, January 1, and maximum is your Feb 28th, second month 2017. So we are actually looking at 2 months data here. Let's look at the Y minimum. So this is, I will look at column 3. Now what is column 3? Consumption. So let's look at the minimum value for consumption, maximum value of consumption. Let's look at the values which can be given as our limits. Now this is the minimum and maximum. Now let's do a plotting for this data which has been narrowed down for consumption based on my data. So I'm saying my first column, which is mod data, and then third column, which is consumption. I'm giving some naming convention for, namings for your x-axis, y-axis, what is my consumption, or what is my title here, what is the color, and then you see I'm using X limit to give the minimum and maximum limit and Y limit. So let's look at this data. And if you look at this data, it is specifically for 2 months. And again, I can look at the pattern here. What I can also do is I can add some grid here, so I can basically look at this data and make more meaning out of it. So it is bi-weekly data, you can see. Now I can add a line here using ab line, and then I can basically choose what lines I would want to add horizontally. So that basically allows me to dissect the data and look at data in a more meaningful way. I can also add vertical lines. So vertical lines is, I'm saying sequence will be minimum, maximum, and I'm saying an interval of 7. So let's do this. And this basically has added some lines every week. And you can see at the end of week, it is dropping, and then it is starting again. It peaks somewhere in the mid of the week, and again, it drops down. So this is, you're looking at your consumption data, right? Now what we can also do is we can create some box plots. So when we looked at zooming in data for Jan and Feb, you can add some data points like this. So consumption is highest on the weekdays, as I showed you here, and lowest on the weekends. So this is what we are seeing when we are breaking the data or zooming it further for a couple of months. So we have vertical grid lines, and we have nicely formatted tick labels, that is Jan 1st, Jan 15th, Feb 1st, and so on. So we can easily tell which days are weekdays and weekends with use of these grid lines and basically breaking it down. So there are many other ways to actually visualize your time series data depending on what patterns you're trying to explore. You can use scatter plots, you can use heat maps, you can use histograms, and so on. Now, moving further, we would want to explore the seasonality, right? So when you further explore the seasonality of our data, we can use box plots basically to group the data by different time periods and display the distribution for each group. Now, how do we do that? Let's come here and let's see how box plot works. So I can just do a simple box plot, and I can choose my consumption column, and that gives me just the consumption data, but this really does not give me any meaning. I can look at solar data, I can look at the wind data, and we can also see some outliers here. So we can create box plots, but if we would want to do a box plot, what is box plot? It is basically a visual display of your 5-number summary. That is, you want to look at your mean, median, you want to look at your 25th percentile, 50 percentile, or 75th percentile. So we can use a quantile function, use the consumption column, and then you basically give a vector which shows you 5-number summary. So that's your quantile. And then let's do a box plot. So if you are looking at quantile, it tells me what is the minimum, what is 25th percentile, 50, 75th, and 100. That's from my consumption column. So let's create a box plot for consumption. Let's give it a name as consumption. Let's give y-axis as consumption and a limit for y-axis. Now that's my consumption graph. So I can look at yearly data. Now that will make more meaning rather than just looking at the complete consumption data. So how do we do it yearly? So we will say consumption, and then I will say the year column. So it is consumption, but grouped based on year. So here I can give x-axis, y-axis, and I can give y limit. So let's create this, and this makes more meaning. We can give some coloring scheme here, but now I'm looking at 2006, 2007, 8, 9, and so on. And we can look at the data. What is the range, right? It gives me 5 percentile, or sorry, 5 number summary of the data per year, and it basically allows me to look at the seasonality of this. Similarly, we can create box plot by just giving consumption, yearly grouped, and here I'm giving the title as consumption, y-axis, x-axis, and y limit, wherein I can also use las. So this is one more feature which you can do, and that basically will give me the tick points. If you compare this one to the previous graph, so when I created this previous graph, I had 2006, 2008, and I had from 600 to 1800. And if I go for the next one, I am basically seeing more useful information. Now let's look at monthly data. So I would want to group it based on months, and let's create that. So this gives me the monthly data where I'm looking at months, and I could select a particular year, or I can just do a grouping based on months. So I can have multiple plots to see a difference here. So let's do this. Now let's create a box plot for consumption, which is monthly data, and let's give it a color. Let's look at the wind data, which is again grouped monthly, and let's look at the solar data, which is grouped monthly. Now if I zoom in, it basically gives me the seasonality of the data for your wind, for your consumption, for your solar. So what we are doing is we are creating these box plots which are giving us values. Now what I can also do is I could look at the day wise also. But before we look into this, how do I infer some information from these box plots which are being created? So this is what we have done, where we are looking at the data for month, and these box plots give me year seasonality, which we were seeing in earlier plots, but give some additional insights. So if I look at the data here, it tells me the electricity consumption is generally higher in winter. Now this is based on months, so we can see consumption is higher in winters and lower in summer. So we can obviously look at our plot, we can see where it is lower, where it is higher, and then we can look at the median and lower two quartiles are lower in December and January compared to November and February. So that is, you look at the quartiles and you will see that the median and lower two quartiles are lower in December and January. Here Jan and December, so you can look at from my plot. Now this is giving you some idea on seasonality. Now that might be due to business being closed over holidays. Now this one we were also seeing when we looked at time series for 2017 only, and box plot basically confirms that there is this consistent pattern throughout the years. Now when you look at your solar and wind power production, both will give you a year seasonality, what we are seeing here. And if basically I look at the data, so it depends on what parameters you are choosing, but if you look at solar, it will reflect the effect of occasional extreme wind speeds associated with storms and other transient. And since we are grouping it based on months, we can see this pattern is quite evident every year. Now, what we can do is we can group the data day wise. So here, let me again reset this to one plot per graph. Now I'll say box plot. I'll say consumption, which is grouped based on day. Now we know that there is a day column, and let's give a while limit and let's look at the data. So this is where I'm grouping the data day wise. So you look at 31 days and you look at the box plot. So this is where you are plotting it on a daily basis. So you can look at the data, you can break it down to a particular week. So here I have given day and I have chosen all the 31 days, but I can break it down to a week and I can look at the data. So if we look at the data per week or per day, we can basically infer that electricity consumption, where I'm doing a consumption group by day, is higher on weekdays than on weekends. So time series with strong seasonality can often be represented with models that can decompose signal into seasonality and long trend. Now this is an easy way. Now how do we look at the frequency of the data? That could be interesting to see. So let me look at, say, the yearly data which we were seeing here. Now let's go further, and here we have looked at data. So what we will do is we look at the frequency. Now when you look at the frequency, when you talk about frequency in your data, so we have the modified date column which gives me a frequency, and if we really look into the data, that will tell me that the data is on a daily basis. So for that, let's look at my data 3 again, which gives me data, and you can just see all the data or dates are in sequence. So your 22, 23, 24, 25, 26, and so on. I can look at, I can access a dplyr package that is basically allowing me to work in a better way. Now I can look at the summary of this, and for all my columns, I'm seeing what is the minimum 5-number summary, date, and consumption. So date does not show me anything because this is not in a date format, it is just a factor, but other things have the 5-number summary. So we are looking at wind plus solar, we are looking at year and month and day and all these columns. Now what we will do is we will want to find out the sum of each column, how many entries does it have, and we will say the value should, NA value should not be considered. So let's look at this one. So it tells me for my particular columns. So let me run this again, and that shows me for each column how many values you have, and these counts do not include the NA values. Now similarly, I can find out specifically for consumption, I can find out is there any NA value. So I'm saying is dot NA, and let's find out if there is any NA value or missing value in consumption. It says 0. Okay, that's good. If you look in wind, it tells me there are 1463 entries which are NA. Similarly solar, similarly wind dot solar or wind plus solar. So it gives me a count of NA values, that is missing values, and also values which are not missing. So to understand frequency, what we can do is we can find out the minimum on the date, that is the first column, and I'm saying RM na.rm is true, that is get rid of NA values and find out the minimum. And let's look at the minimum value. This is the minimum from my modified date. Now if I would want to get the frequency, I can basically use sequence function. So I can say from X minimum, that is the minimum value, I want to look at the frequency, that is day wise, and let's just look at 5 entries and see if there is a day by day frequency. So let's look at the value of this, and obviously it tells me there is day wise frequency. So that allows me to look at the frequency, look at the type of it. It is an integer, class is a date. So similarly, we can say from X minimum, we can basically look at the frequency month wise, and I can again look at 5 records. So that shows me monthly data, right? So I can extract the data for frequency. Similarly, yearly data, and that's also very useful. Now, we can select data which has NA values for wind. So how do I do it? I would want to find out the wind column, and I want to find out where the values are NA. So I will create a variable, and here I will say my data 3, and then I give a conditional where I say is NA in the column. So let's do this. Now once I've done this, I have said that my selected wind data from my data 3 where we said NA values, and I will give the names to this. So names should be in my data 3. I'm interested in mod data, consumption, wind, and solar. So these are the 4 columns I'm interested in. Let's look at first 10 records here, or first 10 rows. So that tells me these are the values where wind has NA or missing values. I can always do a view, and that gives me the complete data. So it basically shows me 1463 entries, and here it shows me all NA values. So you can look at all the way to the end, and it shows me wind has NA. Solar does have some value here in the last row, but then also if you see, the numbers have a difference. So you have 1461 and then you have 2174. So there is a difference. So there is some data in between where wind has some values. So we have found out NA values. Now what we will do is we will select data which does not have NA values. So I will call it cell selected wind 2. I'll again use my data 3. I will say which, but now I'm saying not NA from this column, and I will select the data for the columns. So I'm interested in looking at 10 records, and this shows me not NA values, so no more missing values. So if I really look at this data as I saw earlier, which has NA, and if I look at these values which are not NA for the wind column, so looking at these two results, we will know that in year 2011 wind column has some missing values. So let's focus on year 2011. So how do I do that? Let's call it a different variable. I'll say my data 3. I will say here, when I say which, where we were saying NA, here I will say the year should have a value of 2011, and I want all these columns. Let's look at the data here, and this is showing me 2011, but we are not seeing all the values. So there are some values, but then there are some missing values also for 2011 based on whatever analysis we have done. So let's look at the class of this. It is basically a data frame, do a view, and this one will help me in finding out where are the NA values. So if you just scroll down, looking at all the data, let's search if wind column has a NA or a missing value, and I will see if there is any missing value, in which column or which row it is for the wind column. So we have all the values which are existing. I could select and search for one specific value, and I'll show you how we can do that. So here, let's scroll all the way down. So it's like you're exploring your data and seeing is wind column having NA or missing value for a particular row. And let's scroll here, and here you see there is a missing value for one particular row. So 13th December 2011 has wind value, 15th December has wind value, but your 14th December does not have, right? Similarly, we can search. So there was only one entry which was missing. Now that could be for some reason, might be it was not calculated, might be it was not tabulated. So we have a missing value, and that can affect my plotting, that can affect my analysis. So let's look at the number of rows in this, which will tell me how many rows we have for 2011. So it tells me 365. So that is basically the number of days in a year. Now we will find out if there were NA values. So we earlier checked total number of NA values per column. That is in your row number 265 to 269. We can see here 265 to 269. So this is where we were seeing, are there any NA values? right? So let's go back here, and we want to find out the number of NA values for a particular year. How do I do it? So I can just do a sum. I will say is NA. Now I'm interested in my data 3 wind column, and I'm saying my year has to be 2011, but I'm finding out the NA values. So let's do this, and it tells me 1, and that's right. That's what we saw when we did a view. Let's see how many non-NA values you have, and that is 364. So that basically satisfies my logic. So it's 364 plus 1 missing, so there are 365. Let's look at the structure of this. It tells me you have modified date and date format, you have consumption, wind, and solar. Now let's create a variable, selected wind 4. I will say wind 3, that is which was having all my NA and non-NA values for 2011. I will say let's find out the NA value, because I'm interested in finding out that particular row. So I'm saying find out where the value is NA, and I want all the columns. Let's look at this one, and this is my specific row which has a NA value. Now we know that data follows a day-wise frequency, which we have clearly seen. Now let's select data which has NA and non-NA values. So let's call it test 1. I will use wind 3, which has NA and non-NA values. But now I will say I want the modified date, which should be greater than 12/12/2001. Now remember, we had, when we were doing a view, we saw that one particular day, or what we see here, 14th of December, there is no date. So I will select a subset of data which includes this NA and non-NA. That is, might be I can take 13th of December and 15th of December. So let's start from 12/12. So the date should be greater than 12/12. That means 13th, and it should be less than 16th. So that is 15th, and the columns, right? So now we have some data. Let's look at this. So I've selected a subset of data. I could have done this using subset also. So I have NA and non-NA values. Now why are we doing this? So sometimes you might have some data for a particular column, and you may want to find out if there are any missing values. Might be you want to fill them up or replace them with something. So that is usually useful when you are doing a trend detection. So say for example, you have data for every month, and might be in one of the months you have missed, or might be you have data for every year collected monthly, and then in one of the years for a couple of months you don't have the data. Like I can say 2016, I have data for all 12 months, 2017, all 12 months, 2018, might be I don't have data for March and June, 2019, I don't have data for same months. So I can forward fill or backward fill them using the previous year's same month data. So we can do that. So here I have test data where I've extracted a subset of data. I can look at the class of this. It is a data frame. Structure of this, it has the columns. Now let's use the library and function and use the tidy R package. And what we will do is we will fill it up. So I will use test 1. I will fill the wind column which has a missing value. Now once you do this, if you notice, it has done a forward fill. So it has taken the previous value and it has just filled up that. So you can fill up the data using different directions, such as up and down, left and right, and so on. So we can take care of missing values in our frequency data, which allows us to basically analyze the data in a better way. Now here we will want to also look at some more data. So this is to deal with frequencies of fill column, wherein you can take care of missing values forward filled. So filling values can be done in different directions, as I said, and you may want to first convert your time series to specified frequency if your data does not have a frequency, but we had. Now if you do not have a frequency, might be you can convert it into a frequency such as weekly, daily, monthly, as I showed you, and then basically you can do a forward fill for the values. So for example, if I have my data, I can break it down into weekly and then look at the values. And if there are any values missing for weekly data, I can use a forward fill. So that can take care of my frequency data. Then let's look at the trends of the data, which is the last part of this project. So basically, let's look at the trend. So when you say trend, what does that mean? So in time series data, you always have some kind of trend. So that will exhibit some slow, gradual variability in addition to higher frequency variability, such as seasonality and noise. Now, to visualize these trends, what we do is we use what we call as rolling means. So we know how our data is spread over year or month or day. But how about looking at a rolling average and see what is the difference? So a rolling mean will tend to smooth a time series by averaging out the variations and frequencies. So this can be higher than the window size. So there is something called as windowing, where you can choose a set of time frame. You can also average out any seasonality on a time scale equal to window size. So this will allow you to look at lower frequency variation in the data. So when we are looking at electricity consumption time series, we already saw there is a weekly pattern, there is a yearly seasonality, which we saw using box plots. So we can also look at the rolling means of the time scales. How do we do that? So for this, you can use some package like Zoo, and then you can basically use a rolling mean using the Zoo package, and you can say what is the frequency with which you want to calculate the rolling mean. Now, how do we do this? Let's look at this data. So here I'm going to look at my data 3, which we have been using so far. Now let's call it a 3-day test. You can give it any name. I'm going to use my data 3. I'm using the pipe in function. Now I will use dplyr and I will arrange the data descending in year. Now you can always break it down step by step and you can see the result of this. So I'm going to arrange this data in descending order of year. So obviously my last one, 2017 or 2018, will be on the top. You want to group the data by year. So it depends on how many years we have, we'll see. So you can group the data by year. Now this data is then used to basically mutate. So mutate function is going to allow me to use this rolling mean. So I'll call it as says 03 day. So I'm going to calculate a rolling mean every 3 days for my consumption column. And basically let's ungroup this. So let's see how this works. Sorry. Yeah, let's look at this. And here, when I'm doing a 3-day test, let's look at the result of this and then I'll explain this. So if you see here, we have the test 3-day column. Now this has the rolling average. Now what does that mean? So first value here, what we see is 1367 is the average consumption in 2017 from the first date with a data point on either side of it. That is, you can look at this date, so 1130, then you look at you are looking at the value 1367 here. So you look at 1130, 1441, 1530. If I take a mean of these, so for example, if I would just do this part, and that is giving me mean, okay, because I have a comment. So let's basically add anything as comment, and then let's do this. So it says me 1367. That's what we are seeing here, right? So you're getting a rolling average every 3 days. Similarly, if you want every 5 days, it takes the 5 values and it gets the mid value, right? So you can always find out the mean, rolling mean for a particular frequency. Now let's do that for 7 days, that is weekly data, and yearly data, that is 365 days. So how do I do it? Same logic, my data test. Now I'm using my data 3, I'm arranging it in a descending order, I'm grouping by year. So when you do a group by year, so earlier when we did a grouping by and when we looked at the data, it was telling me how many rows we had, right? So let's do a grouping by year and let's say test 07. So that's a rolling average every 7 days, and I'm also saying take care of the NA values. Similarly, I'm getting rolling average every 365 days. Might be you can do quarterly, might be you can do half yearly. And let's do this. So let's create this, my data test, and let's look at the result of this. So I will use my data test. I will say arrange based on modified date. Now we know there is a column called modified date. I want to just look at 2017 data. So I'm doing a filter, right? And then I will choose what are the columns I'm interested in. So I will look at the 7 and 365 day, and let's look at say first 7 records. So let's do this, and that basically gives me the consumption value, modified date, year, and my rolling 7-day average or the 7-day mean, which is for first 7 days. And then 365, you will not see the data here, but if I do a view on this, I can basically see the values. So you can always select a particular column to see the values. These are the values for every 7-day rolling average. This is for 365 days, every 365 days. So you see all the values are missing, but every 365 entry, you will have basically some data. Now, let's do a plotting of this and basically visualize this data which we are seeing rolling average. So let me first do a plotting, one plot per graph, and let's do a plotting. I will take consumption data, x-axis, y-axis, color, and give a title to this. So let's create this, and that's my consumption data, which is spread over a period of time, and that's fair enough. But now let's add some more plot to this. So I will add the 7-day rolling average to this. So for second plot to be added in the same one, in R you can use points. So I will say points. I will choose 7 data column, type is line, width, X limit, Y limit, and color. So let's do this. And that's my pattern 7-day rolling average, which basically gives me some kind of trend. Similarly, I can add one more here, and this time I will choose the 365 day and look at the pattern lines. So now you see some dots here. Well, you could do it in a different way. So I can just add legend to this, and I can say legend will be where in x-axis and y-axis. So I'm saying it will be 2500 and y is 1800. So my legend will come in somewhere here. I'm saying my legend will have consumption, test, and this one I can give some names. I can give what is the color. I can say what kind of legend. It explains what is for each color, and then basically a vector. So let's add a legend to this, and I've added a legend. Now you can do a zoom and look at the data, and here I see that my x-axis is fine, but y-axis is going a little out of my plotting area. So I can actually change that. So here I have 1800. How about making it 1600? And let's look at this one. So we can basically go for this one and start again here, plot and points and line, and then add a legend, right? And you can basically place your legend anywhere in the plot. So this basically is giving me the trend, what I'm looking at, my rolling average. So similarly, you can look at the trend for wind and solar data. So what we are seeing here is when you look at trend, this is one more way of looking at it. You can always create plots in different ways. So 7-day rolling mean has smoothed out all weekly seasonality, which we were seeing here in my graph, where you look at every 7-day, preserving the yearly seasonality. So 7-day will tell that electricity consumption is typically higher in winter and lower in summer. So better is you break it down yearly. So here, if you look at every year, you can see when is winter, when is summer, what is the seasonality, what your trend, what you're seeing here, and if there is a decrease or increase for few weeks every winter. So similarly, if you look at 365, now as I said, rolling average basically reduces the variation. So if I look at 365 rolling mean, we can see long-term trend in electricity consumption is pretty flat. Now that's what we are seeing. It's kind of pretty flat. There is not much variation over years if you really join these dots. So we can basically see some highs and lows, and that gives me a trend. Now this is how you can do a trend detection, and similarly we can do plotting for wind and solar. So this is a small project which I demonstrated using R. Now all this code which you have here in the form of a project.r file, you can find here in my GitHub page. This is the document which explains some things. Feel free to download this and you can add details to it. This is the sample data set, which you can also find in my repository in the datasets folder. So continue learning and continue practicing R.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.